Today we're going to be using something called L'Hopital's rule. Now, you're probably looking at it and thinking, oh, it's L'Hospital's rule. No, there's no S, although I will tell you that some history books actually do spell his name with an S in the middle. But anyway, pronounced L'Hopital. I'm pretty sure he was a French dude. And so L'Hopital's rule is going to allow us to do some problems like limits. Okay, so let's say that we had a problem like this one. Let's say we had the limit as x approaches 1, natural log of x over x minus 1. Now, if I were to do this problem, of course I would plug in the number first. No matter what we learn, even after today, no matter what, always plug in the number first. We'll have the natural log of 1 on the top. We'll have 1 minus 1 on the bottom. Hopefully everybody remembers that the natural log of 1 is 0. So 0 over 0. We don't know what that is. Now, you may recall that when we did these problems back in Chapter 1, we called this an indeterminate form, meaning we don't know what it is. Maybe it's undefined. Maybe it's 0. Maybe it's infinite. Maybe it's 12. I don't know. But it's indeterminate. We don't have enough information. Now, to do a problem like this, up until now, we could either simplify it algebraically, but of course there's no way of doing that here, or we could make a table of values. So it is possible to make a table of values for this problem, but there's going to be an easier way to do that, and this easier way is called L'Hopital's rule. Now L'Hopital's rule says that if the limit as x approaches a of f of x over g of x is equal to 0 over 0 or infinity over infinity, then rather than doing that limit, we're going to, the answer, the limit that we were looking for, the limit as x approaches a, f of x over g of x, is equal to the limit as x approaches a of f prime over g prime. So L'Hopital's rule says, let's say you're taking a limit, and let's say you end up with 0 over 0 or infinity over infinity. Then rather than doing that limit, we can do the limit of f prime over g prime, and we'll get the same result. We'll get the same answer. So if we were to try that for this example, going back to this again, now again we got 0 over 0. It's important you show that first. It's important that you plug in the number first and then identify that, hey look, that's one of the forms where L'Hopital's rule applies. And I'm going to put a little LHR, L'Hopital's rule. So that shows, hey, I checked it, it's 0 over 0, it works, I can use L'Hopital's rule. And then L'Hopital's rule says, okay, rather than that limit, let's do the limit as x approaches 1. Well, the derivative of the top is 1 over x. The derivative of the bottom is 1. And now we have this new limit to evaluate. Well, I can clean this up, right? This 1 over x divided by 1, that's just 1 over x. And now I can evaluate my new limit. My new limit, I let x go to 1. This is 1 over 1. My answer is 1. So L'Hopital's rule allows us to find the derivative of these indeterminate forms where the limit is 0 over 0 or infinity over infinity. Now, two really important things to remember. Number one, and this is the most important thing I can tell you here, this is not the quotient rule. Not at all. This is not the quotient rule. We're not taking the limit of the entire fraction. We're not taking the limit of ln x over x minus 1. We are treating the top and bottom as different functions. We're treating the top as one function, natural log of x, treating the bottom as a different function, x minus 1. So derivative of the top is 1 over x, derivative of the bottom is 1. The other really important thing I should tell you is that you should always plug in the number first just to make sure that L'Hopital's rule really does apply. Like I said, every single limit, no matter what we ever do, the first thing we're going to do is plug in the number. If we get 0 over 0, use L'Hopital's rule, or infinity over infinity. If you don't get 0 over 0 or infinity over infinity, then you can't use L'Hopital's rule. And either you're going to get an answer or you'll have to try something else. So let's try this problem. We have the limit as x approaches 2 of x to the fourth minus 16 over x minus 2. Just like every other limit we have ever done, we will plug in the number first. So I'm going to plug in the 2. 2 to the fourth power is 16 minus 16 over 2 minus 2. We're getting 0 over 0. So again, yep, it looks like L'Hopital's rule does apply. Okay. Because L'Hopital's rule applies, we are going to, now again, this is not the quotient rule. I'm going to take the derivative of the top function, which is 4x to the third. I'm going to take the derivative of the bottom function, which is 1, and I'm going to evaluate this again. So now I plug in x equals 2. I'll get 4 times 2 to the third power. 4 times 8 is 32. And so we got our answer is 32. We could have done this problem a couple different ways. We could have factored the top. We could have made a table of values. Either way, we would have gotten the same answer. We would have gotten 32 for this problem. Okay, let's take a look at another one. The limit as x approaches infinity of x squared over e to the x. Again, we evaluate. As x goes to infinity, infinity squared is certainly infinite. E to the infinity power is certainly infinite. So once again, this is the other form where L'Hopital's rule applies. L'Hopital's rule is 0 over 0 or infinity over infinity. We take the limit of, now we're going to take the derivative of the top, take the derivative of the bottom, again, not the quotient rule, treating top and bottom as separate functions. Simplify if you can, but really there's nothing to simplify here. Evaluate again. Once again, plug in the top. 2 times infinity is still infinite. E to the infinity power is still infinite. Oh look, L'Hopital's rule applies once again. Do this one more time. Derivative of the top is 2. Derivative of the bottom is still e to the x. This time I'm getting, if I evaluate, I get 2 over infinity. And now I've got an answer, because 2 divided by a huge number is 0. So our answer is 0. Now some of you may be looking at the original problem and saying, wait a second, when we did the limit as x goes to infinity of x squared over e to the x, when we let x go to infinity, back in chapter 1, we were thinking, okay, let's think of this as, well, as x goes to infinity, x squared is pretty big, but e to the x is even bigger because we know that exponential functions always dominate power functions as x goes to infinity. And then said, okay, so it's like 100 divided by a trillion, which is basically 0. Okay, so this is how we would have done this problem back in chapter 1. And if you want to do that, great, go for it. Nothing wrong with that. Just realize that we also could have used L'Hopital's rule. If x goes to infinity, if you have the limit is infinity over infinity, then L'Hopital's rule will also, can be used. And personally, I think it's easier, but either way would work on this problem. Okay, so let's see here. We've got the limit as x goes to 5 of 2x minus 3 over x plus 4. So let's see, we apply L'Hopital's rule, we got the limit as x goes to 5, derivative of the top is 2, derivative of the bottom is 1, so my answer is 2. Okay, good. So we got an answer of 2. That's nice. Okay, hopefully everybody's yelling at the screen right now because I forgot a very important, I'm very disappointed, by the way, that I can't be there to hear you yelling at the screen. Because of course I did this wrong. I forgot a very important step here. Okay, this is completely and totally wrong. Let me erase that completely. I forgot the most important step, which is to plug in the number first. If I plug in the number, I'm going to get 7 over 9. That's my answer. I don't need L'Hopital's rule. Always plug in the numbers first because, of course, if you don't get 0 over 0 or infinity over infinity, then you're not going to use L'Hopital's rule. Likewise on this problem. If I were to evaluate this first, always plug in the number first. This time x is going to 0. Now the last example, x went to infinity and we got infinity over infinity. This time if I let x go to 0, e to the 0 power is 1. 0 squared is 0. Now remember, this is, I'm going to write positive 0. Of course, it's silly to write positive 0. But what that means is the bottom isn't really 0. Its number's really close to 0. And because x is squared, there are going to be positive numbers really close to 0. And if I've got 1 divided by a really, really tiny positive number, the result is going to be a really, really big positive number. So this time my answer is infinity. Again, didn't need L'Hopital's rule at all for that problem. Okay, so here is your, here are some problems for you to try at your desks. Please go ahead and copy these down, try them at your desks, and then after you've had a little bit of chance to try these problems, then I'll on the next video, I'll show you the solutions for these problems. Okay, so for the first one, we will have, if we plug in 0, sine of 0 is 0, bottom is also 0. L'Hopital's rule applies, so we take the derivative of the top, which is cosine x, positive. Derivative of the bottom is 1. If we plug in 0 now, cosine of 0 is 1 over 1. My first problem, the answer is 1. Second problem, if I let x go to infinity, natural log of infinity is infinite. Infinity squared is also infinite. And so this becomes the limit as x goes to infinity. Now, derivative of the top is 1 over x. Derivative of the bottom is 2x. Now guys, before you evaluate this again, before you do anything else, let's clean this up. Let's make this as simple a problem as possible. 1 over x divided by 2x is 1 over 2x squared. If I let x go to infinity, this is 1 over infinity. My answer is 0. For this problem, if I plug in 0, I'm going to get 1 minus 1 minus 0 over 0, which is 0 over 0. So we can use L'Hopital's rule. Hope I have enough space for this problem. So we get the limit as x goes to 0. Derivative of the top is e to the x minus 1. Derivative of the bottom is 2x. If I plug in 0, I'm again going to get 0 over 0. So once again, I'll put L'Hopital's rule. Pretend I wrote LHR there. And so we end up getting the limit as x goes to infinity. Derivative of the top is e to the x. Derivative of the bottom is 2. And now as x goes to infinity, we have infinity over 2, which is infinity. So our third problem, the answer is infinity. And for our last problem, if we plug in 0, the top is 0, cosine of 0 is 1. We don't need L'Hopital's rule at all. My answer is 0. 0 divided by 1 is just 0. So I don't need L'Hopital's rule for this problem. Okay, that is the end of the lesson. So we understand L'Hopital's rule now. Please go ahead and get started on the homework. Copy down from the backboard and get started on that. Next class, I'll answer any questions if you still have them. I will be around on Monday. Obviously, I'm not on campus today, but I'll be around on Monday so I can answer any questions you've got. And also, obviously, I wasn't able to return your related rates quizzes, so I'll get those back to you on Monday as well. Excuse me, I'll get those back to you when I see you on Tuesday. That's the next time you have this class. Okay, so please go ahead and get started on the homework. Thanks, guys.